In this video, we're going to introduce to you a term called stoichiometry. This is the heart of chemistry. Everything that we've done up until now is to get you to stoichiometry. With this, it's all about chemical reactions. You have to have reactants, products, you got to have the equation, and it needs to be balanced. So that's why we've taught you how to formula write chemical equations, and balance them. Stoichiometry is the heart of chemistry. So before we get into all of the math behind stoichiometry, let's talk about the applications of it. So a car and an airbag. If you've ever been in an accident and you've been hit where there's a pressure plate, then your airbags may have gone off. Now the pressure plates are placed strategically around the car for the parts that can create the hardest impact and that they're necessary. And if you've ever been in one, the airbag inflates and it protects you. It hurts too, don't get me wrong, but it does protect you from hitting your head on the steering wheel or on the dashboard or on the side window. Well, there's a lot of chemistry actually behind that airbag because it's a chemical reaction that occurs. When that pressure plate is hit behind the bumper or on the side of the car, it causes two chemicals to be released and come in contact with each other, and then it produces that gas that's inside that airbag, and so that's what it causes. It's a very violent reaction as well, and that's why the airbag can inflate so quickly in a car accident to save us. But if the people who designed this didn't do the stoichiometry math calculations correctly, you could get an airbag that's not inflated enough and doesn't protect you, or overinflated and actually pops and kind of hurts. You also see stoichiometry in cooking, believe it or not, because cooking is all about mixing reactants, mixing ingredients to get a product like cookies. If you don't mix the right kinds, your cookies don't come out right. If you don't mix the right ingredients or you use the wrong thing, they're not going to come out the way that they should. So stoichiometry is all about cooking as well. And then fertilizers or any type of fuel, gasoline, anything like that, uses stoichiometry. It is the basis of any chemical reaction. And believe it or not, there's chemical reactions everywhere in our lives. So what we're going to talk about today, or to start with in this video, is going to be stoichiometry with food. And we're just going to talk about ratios, because that is all stoichiometry is the ratio between two things in a chemical reaction. So instead of throwing, calcium, magnesium, copper, carbon, nitrogen, oxygen at you, we're going to talk about food. If you don't eat any of this, don't worry. I'm not actually going to make you eat it, so it's not that big of a deal. So in this chemical reaction, if I take 2 eggs and 1 piece of bacon and 1 cup of OJ, don't worry about the P and the C. This is just me abbreviating and being lazy. I get 1 breakfast. This is pretend it's a chemical reaction. Pretend they're actually combining to make something, okay? I realize that they're not actually reacting. But from this, we can come up with a lot of different ratios. We can say, for every 2 eggs, I get 1 breakfast. Or you could say, for every 1 breakfast, I need 2 eggs. And don't make fun of me with the way I say breakfast. Okay. For every 1 piece of bacon, I can get 1 breakfast. For every 1 cup of OJ, I can get 1, and so on. Now that's the base ratio. From that, you can do a lot of calculations. Like if I want 4 breakfasts, then I need 4 cups of OJ. A lot of this you can do in your head, but when we start throwing chemistry at you, it becomes a little bit different. So this is the basis of stoich. It's just relating 2 things at a time and using the ratios. Okay, in the next video, I'm going to get into an actual chemical reaction, and instead of being eggs, bacon, and OJ, we're going to talk about nitrogens and hydrogens.